Thank you everyone for attending the presentation. So for those that were not this morning, I'm the CTO of Corporatings. We are a data provider and we use AI to gather some of the data we get. We are part of several committees with decision makers and standard setters who often get asked by their stakeholders, is XBRL necessary? Given the progress of AI, should we continue to develop XBRL to make new regulations that necessitate XBRL? And I'm here today to give you insights regarding that. And to do that, I'm going to compare what we get when we just use AI on text or documents that are, for instance, graphical and PDFs, with what we get when we use XBRL. My point is not just to show you where maybe AI is not perfect right now, but to show you what we can expect in the future when AI improves, to show you that some things cannot be solved just by improving intelligence. But to start, I want to make a comparison between two types of model. When you want to make a comparison and two various things, you have to first start by defining what's your goal, what's the objective, what's the business case. As my friend Thomas Clement would say, you have to start with that. And my business case is the simple business case of looking for specific information, right? That's my goal as a data provider, and that's the goal of most of my users. They want us to give them specific data. For instance, right, in the old model, we used to require financial analysts to come with a PDF and a question. I want to have the free cash flow of the company. And then they had to look through the PDF for that information and then get that information into their specific tool, which usually would require some copy-paste or some retype, depending on whether the PDF was good or not. This was deemed to be not good enough because the search process itself was not reliable, right? You might be having documents that you don't understand because they are in different language. The presentation is unknown. The standards allow a lot of freedom in terms of presentation, in terms of how you are going to disaggregate the information. And then the process of also actually getting the information into the final tool were also deemed to be not good enough because you could have a lot of work to do that retyping, especially if the data was disaggregated, and it was also error-prone, right? So that model needed to be improved. Generally speaking, to improve the model, you can act on any of these separate modules. Although they are not independent, you can try to improve the source format to make it something that is easier to understand. You can try to work on the question syntax to have a better defined question and not just ask questions in natural language, for instance. You can try to work on how you're going to look for the information in the file. And of course, you can also work on the answer format to have something that is easier to put into other tools, right? Now, these are not independent, so when you improve one, this comes from the trade-off usually. And the model that XBRL International developed was the creation of a standard where the document itself was in a precise language, and the user would have to come with a precise question as well, where if you ask what's the value of the fact linked to the concept named revenue for this exact date with no dimension, for instance, you could get the value. So in that form, you also have a precise way to ask for that, right? Usually in form of an XBRL query processor that will read the document or database created from XBRL, and you will get some very precise data in a technical format that can be easily put inside a document, right? But right now, we are having the question that is a challenge to that, saying we could also have another model where we still get the PDFs, and you can just come with a natural language that is not technical and use the power of AI to get another answer in a natural language. So like I said, all of these need to come with trade-offs. In terms of XBRL, the trade-off is you get a much more precise result in terms of the answer that would be facts, technical things that you can have a really good idea of what they mean and easy to use into a tool. And the process itself, the query processor, will also be precise. You know exactly what it does and why it does what it does, right? But To do that, you have to ask the preparers to prepare a new format, XBRL, or to add a layer into their report, which is inline XBRL, which is additional work, right? Compared to a PDF, there is this work of translating that needs to be done. And it's also sometimes harder for the user because they need to know the exact vocabulary they have to ask the question, right? So, of course, since it requires more work for some of the stakeholders, they are looking for other kinds of solutions, which is the AI model where you can just ask the question. Now, the exact performance of AI is often not known, and even though there are some limitations that are known right now, such as the fact that you cannot actually ask any question, you need to do some prompt engineering, which means that, I mean, you cannot just ask what you want, you need to guess what the sort of language the AI is going to actually understand. You don't know how the AI works, so you don't exactly know how it's going to select the information. You don't know that it's going to select the information when it's present, right? You can ask for the research and development expense in a model, and if the model tells you the document does not disclose that, you have no way to verify that, right? And the last one is you're going to get an output that is also language, so that's not easy to translate it to a tool, right? Now, when you say that to proponents of AI, usually they will tell you, well, that's just the current limitation, and at the rate at which the AI is advancing, that will be solved in a few years. So the question is, how do you then decide between these two models, and what sort of arguments can you bring to say, well, I think AI is going to work in the future and solve these possible issues, or is it not? To do that, you have to understand how AI works. And Yanis this morning already gave us a kind of semi-technical explanation of how the LLM works. But I want really to give you a high-level understanding of the fundamental reasons why some things cannot work when it comes to LLMs on just PDF, for instance, or just text. So to do that, we're going to look at some examples of how the AI currently answers some of the queries, and we're going to look at whether that could be improved or whether there is a more fundamental reason why it doesn't work. The first example I'm going to show you is an example in French. Well, one of the advantages from both XBRL and AI is they can allow you to make some queries on foreign languages, right? So I don't expect you to understand this document, but this is the bottom of a balance sheet where you have 3 lines in bold. The first one is non-current liabilities. The second one is current liabilities, and the bottom one is equity and liabilities. Now, French has a specificity that the bottom line of the balance sheet is named passive, and liabilities is named passive as well. So it's the same word for liabilities and equity and liabilities. Consequently, if you ask a language model for liabilities, it's going to tell you the name of the thing that it translates, right, for liabilities, which is passive. So it's going to tell you liabilities are equal to assets for this company, which is, of course, not true. And the question you have to ask yourself here is this an error because the model is not intelligent enough, or is it because of something else? And it's clearly not because it's not intelligent enough, right? It knows how to translate well. It knows how to look for specific amounts. What it's missing here is knowledge, right? It's knowledge that this same word can mean different things, and that we are applying here some specific standards. But you could have this exact same table and the exact same question, and in other context, the answer would be different. Right? So it's not a matter of intelligence here. In the same way, I have a second example here in Spanish, where you've got here an extract from the cash flow statement, where we have the amount of acquisition of payments to acquire new property, plant, and equipment. It's distributed into several figures. You would expect to be able to find that using, for instance, a large language model. But if you ask a question, you will get a figure that's not equal to the sum we had before. And the model will tell you some information. It tells you where it finds it and on which page. And of course, you can go and look at which was the information it gave. The information it gives is actually not payments for property and equipment. It's linked to commitments that the companies has made to invest in new property, plant, and equipment. So it's not actually cash flows, which was what I asked. It's not even expenses, it's commitment, which is something that is completely related, that is not of the same accounting nature. The issue is the LLM doesn't know what accounting nature is. It's going to output words that are very close in nature, right? It's accounting, so it's going not to have a cash outflow, it's going to have an expense. Probably because when it's been trained on general language, it found that expenses and payments were closely related, and that probably in some instances, when you need to compute a payment, you need to have some sort of indirect method where you are going to compute the cash flow from the expense. It's not possible for the model to know this difference because it doesn't have the knowledge. That's not the question I was asking, right? From the language point of view, the answer is correct, right? The intelligence of the model is not the issue here. It's that it doesn't know exactly what sort of difference are important from the accounting point of view. The last one I'm going to show is illustrating the same. Here it's a Swedish report written in English, so this time you can understand it clearly, where once again it's the cash flow statement, and we have a line that's called interest paid, and there is a bottom line also basically giving some information about interest payments related to some specific category, which is lease liability. So once again, I would expect to be able to ask the LLM for this amount of interest paid. That was 671 million. If I ask how much interest did the company pay in 23-24, well, it's once again not giving me the correct figure. It's going to give me interest expense, which is not interest paid, right? And it's going to give me a lot of figures that are related to interest and related to interest expense, but once again, not what I was looking for. You could say that's because my prompt was not precise enough, so there you can try to start engaging in a prompt engineering, which by itself is also something that, I mean, you don't want to have to do when you are doing financial analysis. But let's say you ask specifically how much cash did the company pay for interest. Well, it's still going to answer with interest expense. This is the exact same issue that we had on the Spanish model, where it's going to find the best results it can. And when it has to hesitate between giving you an approximate answer on cash outflows related to interest, and it has to weigh that against a precise answer on interest expense, well, it's going to favor sometimes the precise answer on something that is closely related, rather than give you the vague answer on the precise thing you were asking, right? So in the example we have here, it's giving me figures that are just interest expense. This is the example we have here, where we have a detailed table. So the model is happy because it's found a detailed table where it thinks it can give a precise answer. It is going to favor that over the simple table where I just had one line that was interest paid. So in the end, we have our raw language model on text. So once again, I said this is still necessitating some prompt engineering, but that might improve in the future. But the big issue is it's not able to make key distinctions that are important in a specific domain or for your specific context, right? Just because it's not been trained to do that, and the answer as well requires a lot of attention, right? So if you want to make sure that the answer you get is correct, you need to make sure that you read all of the answer. You need to make sure that you read all of the source document as well, to make sure that the figure you get is not just some figure that has some text in common with what you want. Clearly, if you want to do some financial analysis where you need to pull hundreds of figures from a report, that is not practical at all, right? You need some precise data that can be acted on. So one thing that maybe you can say regarding to that last answer is you could just ask the LLM to give you the precise figure, right? You just say, just give me the answer and don't try to give me complex explanation. So I know that I can just read the text and use that. Well, if you were there this morning when Yanis explained how LLMs work, you know that LLMs work with flow of words. The thinking in the AI happens at the same time as the writing. If you ask the LLM to write less, it's going to think less, right? So that's something that might be improved in the future with different technology that does not exist yet. But the fewer words you ask, the worse the performance is going to be by nature of how the model works. Now, an idea that's been proposed and explored by members of the community in XBRL is to replace the document in text with a document in XBRL by thinking, well, if you have precise data defined in a precise language, you can ask with natural language question about specific facts, right? The issue is, even if you've got some specific names for the elements, for instance, it's not going to be easy for the model to choose which metrics are the correct ones. And when I try to do that, right, giving it an inline XBRL instance, it's still selected the facts with the wrong names, because even though you give them XBRL data, they still don't understand why they need to select cash outflows and not interest expense here. So it was a little better. It selected the right amounts on that question for the total interest paid, but then when it needed to use the data for the interest paid on lease liabilities, there again it falls back to interest expense. So the answer was better than on just text, but still that did not solve the issue of not having precise data. So if you look at the sum of what you get when you just replace the text document with an XBRL document, you get a better working model because it has to work on more precise data, right? It doesn't get the ambiguity of language. You have more precise data, but still the issue of being able to ask the right question to get the right answer is not solved. You still get answers in a natural language, and well, issuers still have to do XBRL, which they are not happy with. So to me, that's not such a good solution and not such a good answer to the question of could we use XBRL, could we keep using XBRL with AI? There's one model that will work pretty well that is really close to that. It's to ask the LLM not to produce an answer directly, but to produce an XBRL query. So for instance, let's say you have put all your XBRL data into a database, you can ask the LLM to create a SQL query, right? There are some models already that have been trained to do that, and they work pretty well at making these sort of queries. So then you can just give the XBRL data into the database, ask a question, ask them to make a query, and then you will also get the facts that are much more precise. If you look at what this does, well, issuers still have to do the XBRL, so that's still the same outcome. And you just have one question, which is, can the LM output XBRL queries that work well? One of the issues is, of course, if you ask a question in natural language, will the model know when things are concepts and when they are dimensions, for instance? And the answer is, it can work, but it needs a lot of engineering, right? That's not, the LM is not going to by itself know that things are dimensions or know that things are concepts. And the other big issue is that we need to address, if we want XBRL to be used, generally speaking, and to be reliable, does that mean that every information that is important needs to be tagged? And that's something that we'd like, of course, to do, but the issuers will never accept, and it's not doable to do. So we need to look for other kinds of ideas. And the good news is there are some ideas. So, generally speaking, when you are trying to think about AI and about what should we do, what can we do, right? What can you expect? What's the best way to work? The best idea is to fall back to yourself, your own brain. How do you work? How do you work and how do you learn, right? There are a lot of things that you can do without spending hours learning what things are. And that's an area that's being developed in AI quite a lot since 2023, which you would find usually under the name of few-shot prediction or few-shot classification, for instance. And the easiest way to do that is to show you, for instance, how you work with image recognition. So let's say I ask you this question. You have this image. Is that an image of a pyrophone, right? Well, using just your brain, you might have some idea about that. Maybe something called phone is an instrument, like a saxophone, and then pyro is usually the prefix for fire. So maybe that looks like something that can be used to make music with fire. I don't know, right? You're not sure about the answer, but is that because you are not intelligent enough? Do you think that maybe if humans keep evolving in a few generations, you will have humans that are able to give a precise answer to this question instinctively? That's not the case, right? You are fully capable and fully intelligent, and what you are missing is just some knowledge. And we've touched upon the fact that maybe it would be a good idea to fine-tune models by giving them a lot of data. But what I want to point out is you don't need a lot of data. Here I give you a picture of a German musician that's playing on the pyrophone, right? Just give you one example, and just like that, in just a few milliseconds, you were able to answer the first question, right? Now you are fully confident that the first image is indeed a picture of a pyrophone. It's the same for XBRL. You won't need to feed hundreds of or millions of examples into a model to get that right. And that's what we developed in AI. So basically, you need to have a picture, so something that is in the same format as what you want to work on, and this needs to be tagged. You need to have the information, what is the knowledge I should have from this picture, which is, this is a pyrophone. And then the idea is, if you give to your brain an image, then you are able, right, just with one example, to give a precise answer on that. So if you want to understand financial information really well, what you need is some text on which we've given the outcome of the analysis of this text, right? So we need to have some text with some tagged data that tells us what you should understand from this text, which is, I mean, inline XBRL, right? Inline XBRL is exactly that. You got some text and some information. So if you give an LLM that has a few short architecture, a few examples about some predictions, and you present some text that is not tagged, and you ask the question, is the information I'm looking for in there, is going to be able to work like that. So for instance, if you want to find interest paid in a report, you can just give text, right? And you give a few examples, just a few, like it needs to be representative enough, but that can work with just a few reports. You give a few reports of examples where you have interest paid, and a few examples of reports where you don't have interest paid, and then you can ask the question, and you will get the answer. The huge benefit of that is, well, the text is just text, right? So you don't have the burden of having to tag the text you're looking to work on. The question is in natural language, so that works well. The conventional model, it's only going to output XBRL facts, so the universe of answers is much more precise when you have just natural language, so it's much easier to test, and the answer is going to be XBRL facts, right? Generally speaking, the nature of answer will be the same as the tag you have on your examples. And where we had the issue that we wanted all the information to be tagged, here the only thing we need is to have some representative information tagged. And generally speaking, for instance, if you want to understand all of the financial information of a company, you just need to have, let's say, the main financial statements plus all the tables where they're defined some new figures to be tagged once, and then you will be able to interpret all other documents the company says where they stay consistent with that. If you've got a representative set of reports, you can also start predicting and understanding reports from other companies as well, and you will be able to do that so long as the standard itself does not change, right? So if the standard changes, of course, you would not normally be able to use AI because you would have to retrain things. With this system, as long as you are able to provide new instances, that will work. And that's where you can also have the next step of that, which is you don't just give an instance, you also give a taxonomy, right? You say, when I had this document, this text, and this taxonomy, tagging interest paid looked like that. So the model is going to learn that this is the relation between the taxonomy and the tag we have. And you can go towards the model understanding that if you change the taxonomy, it also needs to look at specific parts of the taxonomy. So when you apply that to a model and you do a few short questioning on an example where you just input the PDF and you also gave to the model some examples of interest paid and interest paid on lease liabilities, it's going to give you the correct answer, right? So in terms of key takeaways, like how can you think about AI versus XBRL? And if you need to answer the question, do we need XBRL in the future? The answer to that is, in general, to answer a question, you need to be intelligent and you need some knowledge, right? Just because you cannot answer a question doesn't mean you are not intelligent. And just because you cannot answer a question means that you can answer the question in the future if you only improve the intelligence. You need to have some knowledge. Right now, the performance you are seeing in ChatGPT, where you could ask ChatGPT, hey, this picture, is this a picture of pyrophone? It would not use the large language model or the image recognition model to do that. It would go to Google, ask, can you give me an example of a picture of pyrophone? And then it would use that to use that. If you want to do that on financial data, you need the same. You need a reference data telling you what information is, and that is exactly XBRL, right? If you ask the language model, is this interest paid? It needs to have some sort of reference saying, hey, this is an example of interest paid. Now you can say whether in this specific report, this is also interest paid, right? And if you want to have answers in a structured format, the specific example needs to be also in a structured format, right? The model will give you, like I said, the exact same format as the tag you gave it, right? So if you have an image and you say, this is a pyrophone, the answer we'll get from the LLM will be, this is a pyrophone. If you give them an XBRL fact, the answer you will get will be an XBRL fact. The language will learn to give you answers in the same structure as the tags you give them. Now, in terms of the community, I think, answering questions about how can we use AI with XBRL, the key takeaways I'd like you to take from this is don't necessarily try to work on making LLM queries on XBRL. LLMs, they don't know XBRL. They can read maybe XML or they can read attributes, but they will not understand what it is. So don't necessarily try it, and it also has the inconvenience of you saying this will only work with XBRL. So we're not gaining any capability to understand other types of documents as well, which is the same because, like I said, XBRL allows us to understand any kind of documents that use the same vocabulary as an inline XBRL instance. Something that I did not talk about here is you can also try to feed the LLMs with XBRL knowledge, saying, hey, if I have an instance here, here's how I can understand it. Because the downside is, well, you will only have answers that are text, which is not what we want, right? We don't want to ask a question and then get some explaining sentence. You want to have some data that can be then used in calculation models and things like that, right? So my idea would be to go the way of trying to extract the knowledge from inline XBRL and then use that as a training set, as I explained, right? Feed it to models and teach to models how you should understand text by using inline XBRL instances as the examples of how to interpret the text. So if we could, as a community, try to answer all these questions, all the objections to AI in a way that is really taking advantage of what XBRL can do, I think we can convince decision makers that, yes, this is a necessity, right? Myself, as a data provider, I wouldn't see myself working without XBRL right now. Because, like I said, there is too much ambiguity in just text. We created AI, we created XBRL because raw text was too hard to understand. And it was too hard to understand not because we were not intelligent, but because we actually needed some more clarity in the figures we got, right? So that's not going to change with AI. If the text is ambiguous, AI will not be able to get answers as well, right? So I hope it was clear for everyone, but don't hesitate if you have questions. I would expect you to have questions. So thank you, everyone.
Thank you very much. Again, so it's a very great insight. Okay. So I'd like to take a few questions. Any questions? Yes.
Hello. Given the nature of the XBRL data, where it sometimes can be highly dimensional, and that complicates things a lot when you're asking for specific data. If you're trying to get maybe the amount of assets, it's really easy because it is usually in a dimensional context. So what approach would you recommend, if we're gonna, for example, we have a breakdown of credits where you have even implicit dimensions. You add dynamic items to the list because maybe this month you have new credits and you need to disclose, I don't know how far it goes, the credit in the timeline and different currency, sorry. So what would be your approach there, to be able to talk to this or to use ChatGPT to ask for information about the credits that may be due sooner than others,
Well, you would not be able to do it with ChatGPT directly, but for instance, what we do internally, so that's like I said, the model needs to be able to understand when you're asking questions, what is the nature, right? Is it a company? Is it a concept? Is it a dimension that you are going to ask? So what we have is a first, like I said, that's where the interpretation of the initial query and the translation into technical syntax happens. And what we do is we have indexed all the possible different concepts, dimensions, and values we have inside our XBRL database. And so when the question will be asked, the first thing the LLM will do is ask the index in which of the index does this term happen, right? And in which index does the combination of words happen. So if somebody asks, for instance, for some information in France, for instance, France will appear in our list of members for the geographical dimension. So the tool will understand that because somebody asked for France, we're going to look for data that was distributed along the geographical axis, for instance. Some of it will be obvious like that, but sometimes you also have to have questions. For instance, if somebody asks for a time series, well, how do you know that you need, for instance, to look into the dates field, right? And that's something where we have ourselves to do a few annotations where we'll say this type of question, you should ask for this specific dimension. So we provide a few examples of SQL queries where we translated this specific questions, right? There is some learning to do in that where you have to provide some example of how you are going to translate natural language into specific queries, right? But the advantage you have of doing that over just asking for a whole document is the number of probably columns you have in your tables are limited enough that that's something that's doable, right? And you'll still have an idea of how it works exactly. So when you don't get an answer, you know why you're not getting an answer, and you know which things you need to improve on. If you just have raw AI, the AI will output a stream, and you won't have any idea of how to improve it, except with what Yanis presented this morning, which is human reinforcement, where you just ask users to say, do you like this answer or not, right? Which is not something you can reliably work on with such large documents.
Okay, excellent, thank you.
Any other questions? Okay.
So in one of your examples, you said that LLMs was not able to understand XBRL data, and you had mentioned limitations of context ID. So what was the source XBRL document that you had given to it? Was it an inline XBRL document?
Yes, it was an inline XBRL document. I also tested it with just instances as well. Okay. And if the document is small enough, it's going to be able to link the things together. But generally speaking, it doesn't know the technical relational data, and it doesn't know that context ref is a reference to an ID. And you could train them to do that if you gave them enough XBRL instances. But the issue is this fine-tuning. You would require huge amounts of XBRL data, and you would also need to make sure that the data is not biased, for instance, right? Like if you could feed it tons of itself reports, but then it wouldn't be able to work well on other reports, right? So I think this task can be done, but it's too costful, and it would be too hard to take into account the changes into the standards.
I think one possible solution is using XBRL-JSON, because then you get rid of the context IDs and the references, because every fact has, explicitly, the metadata mentioned to it. So you need not train us to, how do you read that.
But then you don't solve, for instance, the issue with the link bases, where if you also want to get the information.
So that's what the taxonomy OM effort is about, and we're looking forward to it.
Right.
Yeah.
Thank you very much. One more question, maybe, if you have. Okay. Yes.
I think that another approach could be describing the fact, You're saying that the LLMs don't understand XBRL, but a standardized way to treat the data would be to have a transformer that can convert the fact to a text interpretation of it, to prepare a phrase that says the total amount of assets reported by the company, this is like that.
This is the one I talk about in the middle, where you could teach how to interpret XBRL. But the issue is your input is XBRL, so that will work if you give it an XBRL instance. But if you have a new PDF, for instance, like an earnings report that is not XBRL, that will not allow you to actually gain some new knowledge, right? And our goal as data providers is to be able to translate any input we have into knowledge.
Yeah.
And
that's why I think that you could combine the taxonomy, which has already the relationship between the dimensions, and also you combining it with a vector database, because the resulting text would be large, and given the limited context of specific LLMs, maybe that could be a standard way to be able to have this conversation with the data without having to provide that many hints or having to worry about queries, but dealing actually with just plain text.
Plain text or presentation data, for instance, or inline XBRL. And the other issue with having explanations is the output is language. But I don't want, as a data provider, I don't want explanations on output. I want facts, I want specific value. So XBRL as an output format is already perfect for me. So
that's a vector database that would link the text that you generated from describing the facts, and it would link back to the actual facts that you use, so you could ground your answer to say, this is the answer that I'm presenting, and this is the facts that I use to prepare the answer.
Yeah, but in the end, you're just making a model that predicts a specific fact. Whether you have an intermediary language in there is not going to affect the end result you want, right? If you give some text just explaining what XBRL means, you're going to have the quality issues of interpreting language in the middle. So it's just another layer of accuracy that you have to work on, and on which, like I said, you don't have any real control over how precise it's going to work, and maybe other types of inaccuracies and mix-up between words is going to do.
I get it. I understand where you come from. But I think it would be interesting to explore it, especially with
this is all my opinion and the sort of direction in which my company is doing. I, of course, encourage you to try all sorts of research, right? Science is not about agreeing on everything, it's about trying new things. So if you can prove me wrong, do it.
Thank you so much.
Thank you very much. Okay, so again, please join me with a big hand for him.